Okay, so I'm going to go over 4 examples in this video, but first I want to make this clear. When we solve an equation with a variable, we are finding all values of that variable that will make the equation true. So when you find a value of the variable that makes the equation true, we call that a solution of the equation, okay? The solution of the equation. So it is whatever real numerical value is going to make that equation true, okay? Because that's why we call it an equation, because it has the equal sign, and that is very important. It has to actually check out in the equation. The solution actually has to make that equation still equal, otherwise it's not an equation. Although sometimes you can get what are called extraneous solutions, but that's a topic for another day. But the long story short is, for now, all you need to worry about is that a solution is the value that makes the equation true. And the extraneous solutions, those are more like in quadratic formulas, that sort of thing. And we're going to talk about that probably in the near future when I start getting to like graphs and that sort of thing, but we are starting really basic right now, so don't worry about that. I just thought I'd bring it up because it is quite related to this topic conceptually. So anyway, so what we're going to do, when you have an equation with a variable on one side, be it on one side or it's on both sides, the point is you need to isolate your variable on one side of the equation. That way, when you simplify that equation, you have basically a variable equals constant form, right? So the variable equals this number, this constant, right? That's what we want. And the way we do that is we apply inverse operations. So we're going to have inverse operations. So those are operations that undo each other, like addition and subtraction, okay? Then you've got multiplication and division, okay? These two pairs all have inverse relationships with each other. So that is very, very important to remember. Addition and subtraction, inverse. Multiplication and division, inverse. Okay? So, start with our first example now that I've rambled on about solutions, and you're probably waiting to actually see the big, interesting part that is actually solving. Okay, so example 1, we need to find the solution of x plus 4 equals negative 12. Okay, so we have the variable x, we need to get x by itself. So to do that, we can apply the inverse operation of addition, right? We're adding 4, so I'm going to subtract out 4. But remember, I got to do that to both sides. That is very important. Otherwise, we cannot say this is an equation because it would not be equal. So subtract 4 from both sides. Negative 12 minus 4 is negative 16. So x equals negative 16. That was fast. But this is the important part. A new step I'm going to start doing. Check, check, check. Okay? Does negative 16 plus 4 equal negative 12? And when you're checking, you can put a question mark above the equal sign because we are checking to see if it actually is equal, if both sides are actually equal. So negative 16 plus 4 is indeed negative 12. So this solution checks out. So x equals negative 16. Okay? Example 2. Example 2. If we have 12 times b equals 18, okay, so this is no longer the easy peasy addition subtraction. We are dealing with some division and multiplication here because we have 12b, that is multiplication. We need to get b by itself. So how we can do that, we divide both sides by 12, okay? So that cancels out. Now 18, so technically that means b equals 18 divided by 12, but usually when you are finding a fraction as your final answer, you want to put it in simplest form. You want to simplify it to its smallest factor. So in this case, 18 and 12 both have a factor of 6, right? 6 times 3 is 18, 6 times 2 is 12. So you can divide like so. 18 over 12 divided by 6 over 6 is 3. 18 divided by 6 is 3. 12 divided by 6 is 2. Okay? So that is our solution. But does it check? Does it work? So we're going to check. So does 12 times 3 halves, or 3 over 2, equal 18? Well, you can rewrite 12 as a fraction, 12 over 1 times 3 over 2, and what you do is you just multiply the numerator and the denominator when you're simplifying this kind of expression over here. But you can also reduce early on in the process. So I see, if I look this way, cross multiplication, 12 and 2 share the factor 2. So I can divide 2 by 2 and get 1. I can divide 12 by 2 and get 6. 6 over 1 times 3 over 1 is 18, and that does check out to 18, so this works. Now, moving on, example 3. We have negative 27 plus 6y equals 3 times y minus 3. Okay, so, oh, and for the record, up here this was subtraction property of equality. So in the same pattern, we would be using division property of equality, I believe you'd call it, yeah, because we were doing the same division on both sides. Okay, so here we're going to apply the distributive property first. So negative 27 plus 6y equals 3y minus 9, okay? Now we are going to pick one side. Now notice up here, I want to make a note real quick. Examples 1 and 2 are examples of one-step equations. You notice we only had to do one operation. We only had to do one inverse operation to find the solution. Here, though, we have to do more than that. That's why it's a multi-step, multiple steps, more than one step. So what I'm going to do is I'm going to go ahead and, let's see here, I'm going to add 27 to both sides to get rid of the constant that is on the left-hand side. So this cancels out. Negative 9 plus 27 is 18. So we have 6y equals 3y plus 18, okay? Now I'm going to subtract 3y from both sides to get rid of this variable term, on the right-hand side. So 6y minus 3y is just a positive 3y, so 3y equals 18. Now, divide both sides by 3, y equals 6. But does this work? We have to check. So, the solution was that y equals 6. So does negative 27 plus 6 times 6 equal 3 times 6 minus 3? That's what we're going to find out. So negative 27, 6 times 6 is 36. 3 times 6 minus 3 is 3. Negative 27 plus 36 is 9. And 3 times 3 is also 9. So therefore, this solution works. Now, I'm going to do one more example. Whew, got enough space here. It's good. Example 4. That's why I'm trying to enunciate what I'm saying, just because I know the video, you might not be able to see it as big as I am right now, but the point is understanding the concept. So 3 times 2x minus 1 minus 2 times 3x plus 4 equals 11x. I know that looks like a monster of an equation to solve, but we can break it down. So first, distributive property. 3 times 2x, that is 6x. 3 times negative 1 minus 3 minus 2 times negative 2 times 3x. That's, so we have a negative 6x over here. Negative 2 times 4 minus 8, and then you've still got 11x over here. So now we're just going to take away the parentheses. I just put them there kind of as a safety precaution while I'm simplifying during that first step. So now we can move like terms together. 6x minus 6x minus 3 minus 8 equals 11x. 6x minus 6x is 0, so don't worry about that. So you just have negative 3 minus 8 on the left-hand side, so that is negative 11 equals 11x. You divide both sides by 11, and you get negative 1 equals x, or x equals negative 1. But again, we have to check. We cannot just assume. There is no assuming in math. You check. That is not how you do math. You don't assume things. You check them. That's why it's a system. Okay, so does 3 times 2 times negative 1 minus 1 minus 2 times 3 times negative 1 plus 4, does that equal 11 times negative 1? Well, we're going to find out. So 2 times negative 1 is negative 2 minus 1, and then you've got minus 2 times 3 times negative 1 is negative 3 plus 4. 11 times negative 1 on the right-hand side is negative 11. So now you've got 3. Okay, negative 2 minus 1, that is negative 3. Minus 2. Negative 3 plus 4 is 1 equals negative 11. And we're still curious, so question mark. 3 times negative 3 is negative 9. Negative 2 times 1 is minus 2. And then we've got negative 11. And negative 9 minus 2 is indeed negative 11, so this solution checks out, and x does equal negative 1. So, like I mentioned, up here, the first two examples are one-step equations. Examples 3 and 4, on the other hand, as you can see, they're longer because they are multi-step equations. So, that is because we have variables on both sides. So, just in general, when you have variables on both sides, you want to manipulate the equation. You got to choose one side that you want the variable to be on, and then remove that variable from the other side. So like here, we had y on both sides, but I was able to get it to the point where we had y just on the left side. And then you could just simplify it like we do up here. And over here, you had x on both sides. So you just distribute, you combine, you simplify, you move x. So over here, x canceled out over here, so we had x only on the right-hand side, so we just simplified. And you have this kind of variable equals a constant form. That is what you want, a variable equals a constant, right? So we have like b equals a constant, x equals a constant, y equals a constant, x equals a constant. So you really just follow that process. It'll help with even longer algebraic equations when you're simplifying. So yeah, so that's all I got for today, and until next week and more algebra, Maya out.